Compute factor of safety based upon the distortion energy theory for stress elements at A and B for the member shown in figure below. The bar is made of steel with yield strength of 280 megapascal and is loaded by forces F equal to 0.55 kilonewton, P equal to 4.0 kilonewton, and T is equal to 25 Newton meter. Right? So this is the question, and the diagram which is given is this. So this is a rod or a circular bar which is fixed at this end to a vertical column, and there is an axial pull P along the direction X. In the direction Z there is a force F, and at this phase there is a twist T, right? Torque T which is applied. Now considering all these three, I have to find the factor of safety based on stress element A and B. He has given 2 points. A is this, which is in the plane XY. This is Y, vertical axis is Y. This is X. So in the plane XY there is a stress element A, and in the plane ZX there is another stress element B, right? So you have to find these two. At these 2 points, what is the factor of safety? Right, now let us start solution. Given he has given SYT first. SYT equal to 280 megapascal. Then F is 0.55 kilonewton. We need the forces in Newton, so it will be 0.55 into 10 raised to 3 or 550 Newton, right? Then P is equal to 4.0 kilonewton, so it is 4 into 10 raised to 3 or 4000 Newton, and torque T is how much? 25 Newton meter. 25 Newton meter is 25 into 10 raised to 3 or 25,000 Newton mm, right? And length of the bar is given as 100 mm, and diameter D is 15 millimeter. That is given in this diagram, right? That is all the data that is given. Now first let us find the factor of safety based on stress element A. Or before that, let us individually consider the effect of these three forces, right? The force P, which is acting axially along x-axis, produces tensile stress, right? Tensile stress is how much? I'll call this as sigma T because I have two different normal stress. There is bending stress also. Sigma T is equal to P by area, right? first let us calculate the area of cross section of the rod. A is equal to pi d square by 4. So d is 15. Pi into 15 square by 4. Let me just calculate this quickly. 15 square into pi by 4. So it is 176.72 millimeter square. Right? Now let me just substitute the value in this. P is how much? 4000 by 176.72. So that is equal to 4000 by 176.72 is 22.64 megapascal. So this is the tensile stress in the direction x. Now F is along the direction z, so because of which this rod will try to bend in this direction, right? It will bend like this. So the force F, which is acting at the tip of the bar in z axis or z direction, causes bending stress in the bar. The bending is bending stress is sigma b. So sigma suffix b is equal to my by I, right? Now M is the bending moment. So here this is a cantilever, so there is only one force acting at this point. So the bending moment is force into perpendicular distance, F into L. So M is equal to F into L. F is how much? 550 Newton into L is 100. So it will be 55 into 10 raised to 3, correct? Newton mm. Then Y is equal to d by 2, which is equal to 15 by 2, which is 7.5 millimeter. And moment of inertia I is equal to pi by 64 into d raised to 4. So let me just put this value. B is 15. So 15 raised to 4 into 5 by 64. So it is 2485.1 mm raised to 4. So I got all the values. Now I can calculate the bending stress. Therefore, bending stress sigma B is equal to MB is this 55 into, just put in brackets there, Y is 7.5 and I is this much. Okay, now let us calculate this. So 55,000 into 7.5 by 2485.1. So it is 165.989. So I'll just round it off to 166 MPa. Right? So that is the bending stress because of F. And lastly, I have the torque. The torque T produces torsional shear stress in the bar. So this is given by torsional shear stress is tau. Tau is equal to 16T by pi dq. Pi dq. We have done this already in the torsion section, right? So I'm gonna just substitute this value of T and D in this. So torque is 25 Newton meter, so 25,000, and D is 15. This is equal to 16 into 25,000 by 15 cube into pi. So this is 37.73. 37.73 MPa. Right? Now I have three stresses because of three forces that is acting on the bar. Because of P, we have a tensile stress sigma T. Because of F, I have bending stress sigma B, and because of T, I have shear stress tau. Now you have to find the factor of safety at 2 points A and B. Now A and B is not at same location. A is in the plane XY plane, right? And B is in XZ plane. So the force P is inducing the tensile stress sigma T at all the points on the cross section. Anywhere on this cross section, the sigma T is same. The torsional shear stress tau is proportional to its distance from the center of the shaft or the rod. So A and B are at same distance from the center of the rod. So tau is same. Now only difference is because of sigma b. So I just made a sketch like this. See, I am viewing from the top. Now this is the neutral axis of the bar. This is the cross section, right? Because of force F, the rod will get, or it tends to bend in this direction, right? Now here on the upper fiber I have compressive stress, right? And on the lower fibers I have tensile stress, whereas the neutral axis will not have any stress, right? So at the upper fiber it is compressive stress, lower fiber it is tensile stress, and in the neutral axis there is no stress at all. So at point A there is no effect of bending stress. At point B there is tensile stress because of bending stress. That is the only change in this calculation. Now let us find the theories of failure. Sorry, factor of safety. Okay, now having found this, one, FOS based on stress element A, right? Now you have to draw the stress element A. So let me just quickly draw the stress element A. Let me just draw a square or a rectangle like this. Now in this I have tensile stress in the x direction. So you have to show like this. So this is tensile stress in x direction, sigma t. And then there is shear stress. So shear stress direction you can show anything. It is not very important here because it will get squared inside the bracket. So whether it is positive or negative, it really does not make much difference. So we need to just show two opposite forces like this, and there is a resisting force in opposite direction like this. Okay, so let me just write this as shear, and this is tensile, and this is x direction and this is zx direction, right? So I'll just copy this into my the stresses on the element A is shown in figure below, right? Now what does distortion energy theory says? This is the distortion energy theory. Here there is stresses in only two directions. So sigma 1 square plus sigma 2 square minus sigma 1 sigma 2 is greater than or equal to sigma t square, right? So this is the distortion energy. So now you have to find the sigma 1 and sigma 2. Let me make this little small. Principal stresses are sigma p is equal to, now I have only one direction normal stress, so I will just say sigma by 2 where is plus or minus in this, yeah, right, plus or minus root of sigma by 2 whole square plus tau square, right? So this is the general equation. Now if you put plus, you get the major principal stress. If you put minus, you get minor principal stress. So I'm calculating both together so that I can save some time. I'm running out of time now. Now sigma is how much? 22.64. This is 22.64. This will also be 22.64, and tau is 35.37. Right? These are the answers I have got. I'm just using this. Now, from this, if you put plus, you get major principal stress. If you put minus, you get minor principal stress. So let me just put plus first. So this would become 1. Sigma 1 is this plus this. This is equal to 48.46 megapascal. Similarly, minor principal stress will be sigma 2 is sigma by 2 minus sigma by 2 whole square plus tau square. So we'll just put minus here. So this is minus 25.82, right? So I have sigma 1, sigma 2. Now you put in this expression. According to distortion energy theory, sigma 1 square plus sigma 2 square minus sigma 1 sigma 2, I'm just equating it to sigma t square, or I will call this as sigma permissible square, right? Now you just have to substitute the values in this, or sigma 1 is 48.46 48 25.46 plus minus 25.82 into 48.46 into minus 25.82, right? Or sigma permissible is equal to, what is that I get? I have to calculate, I don't have that answer. So it is 48.46 square plus 25.85 square minus 48, sorry, plus 48.46 into 25.86, because minus of minus it will become plus, so it is this much. Root of this is 65.66. Now factor of safety is SYT by sigma permissible. Now